Before we begin, let me tell you something very simple. If you understand propositional logic properly, almost every topic in discrete mathematics becomes easier. In today's class, I'll explain exactly what you need for exams without wasting a single minute. So let's start with the basics and build everything step by step. Let's start from the foundation. A proposition is a declarative sentence that is either true or false, nothing in between. For example, Dhaka is the capital of Bangladesh. It's true, but 0 plus 0 equals to 2, it's false. These are propositions, but be careful. Not every sentence in English is a proposition. Like, sit down. This is a command, not a proposition. A question, not a proposition. Here, it depends on the value of x, so this one is also not a proposition. So in short, proposition is a sentence with a definite true value. We often use symbols like P, Q, R to represent propositions. For example, let P equals it is raining, Q equals I am at home. This is the heart of propositional logic. Using connectives, we build compound statements. Negation simply flips the truth value. If P is true, negate P is false, and vice versa. This means P and Q. It's only true when both P and Q are true. Let's consider two statements in P and Q form. This means I am at home and it's raining. This means P or Q, the inclusive or. True when P is true or Q is true or both. But English or can be tricky. Let me show you. In English, soup or salad means exactly one. That's called exclusive or, written as this. This is one of the most misunderstood ideas in logic. This means if P, then Q. Just remember, it's only false when P is true and Q is false. In every other case, it's true. Now here's the part students always confuse. From this, we can create three new statements: converse, inverse, and contrapositive. And this thing is important for exams. The implication is logically equivalent only to its contrapositive. If you remember only one thing from this video, remember this. This means P if and only if Q. It's only true when both have the same truth value. Now we recall about the truth tables. Truth tables allow us to evaluate any compound proposition systematically. Here is the important note. If a statement has n variables, the truth table will have 2 to the power n rows. So now if we're supposed to translate English to logic, we should remember these three steps. Step 1. Identify atomic propositions. Step 2. Assign P, Q, R. Step 3. Connect using logical operators. Example. If I go to Harry's or to the country, I will not go shopping. This becomes this. If we were told to translate this English sentence into a logical proposition, we would write this. These types of translation questions are exam favorites. If you understood everything here, you already covered the foundation of all future logic chapters. We have completed the fundamentals of propositional logic. To strengthen your understanding, continue with the next topic, propositional equivalence. It builds directly from what we have covered here.